All right, let's see if we can look at this one. So we got, again, two parametric equations. So this time some trigs involved. X is equal to cosine t, y is equal to sine of t, where t is between 0 and 2 pi. So what would this one look like? Well, let's see if we can come up with the Cartesian equation. For this one, we won't be able to substitute. But if you look at what these are, cosine and sine, I know a trig identity that involves both cosine and sine. We know that cosine squared, um, and I'm going to use t here since we're using t, plus sine squared is equal to 1. That's our Pythagorean identity. Well, if we substitute here now, um, if we had, if we substitute cosine is equal to x, so if I substitute here, that means I'd have x being squared. If I substitute for sine, sine's equal to y, so I'm going to plug y in for sine. That means I'd have y squared, since these are both being squared here, equal to 1, which gives me the equation x squared plus y squared equals 1. Well, that we know what happens when we graph this Cartesian equation. We get, or should get, a circle. This is in the form of a circle here, where it'd be a center of 0 equals our radius squared, so our radius here would be 1. Well, that's just a circle centered at the origin with a radius of 1, which ends up being unit circle. This is what's being graphed here is a unit circle. So if you plug in these different times, you would come around and move around the unit circle in the way that we typically talk about, because if you put 0 in, cosine of 0 is 1, sine of 0 is 0, so you start where we do on the unit circle, and as you move around here, like if we put in pi over 2, cosine pi over 2 is 0, sine of pi over 2 is 1, and so we get a point there, and we're moving in this direction. And also remember when we graph in unit circle, we're saying that x is our cosine value and y is our sine value. Well, that's the same thing here. X is our cosine value, y is our sine value. So we get the unit circle when you graph this parametric equation out. All right, what type of curve is represented or given by this parametric equation? Well, let's for this one, let's look at the calculator here. You can graph out parametric equations on the calculator. And how you do it is you have to change your mode here. So if you hit your mode button and we go down, there is other options down here that we are going to get to. Right now we're in function mode. If you go over 1, you can change to parametric mode. So let's change our calculator to parametric mode. Now let's go to our graphing menu. And you can see now in your graphing menu, instead of having just y, we have both x and y. So we can enter in equation for x, and we can enter in an equation for y. So our x function is sine of 2. And now when you hit this button that usually gives us x, it's going to give it to you as t instead, because we're in parametric mode. All right, and then we need to enter in our y equation here, which is cosine of 2t. And now we can graph. I'm going to hit zoom. I'm going to graph this under our decimal one, number 4 here. So if we graph this out, looks like this is also giving us unit circle. You can see that it gives us a circle there with a radius of 1. So this one also is going to give us a unit circle. It's going to be like this, and we get the unit circle here. So what we've seen then is that both the last two examples that we did show that different parametric equations can represent the same curve. The first one we had gave us a unit circle. Also, this one gave us a unit circle. But the parametric curve did go in a different direction this time. When we graph this one, if I go back to my calculator here and I hit trace, you can see that the initial point here, I'm going to change up. I'm going to go to my settings here. I want this to start at 0 here, yeah. I'm going to change also on my window to this to start at 0. All right, so if I go back and trace now, you can trace. You can see that the initial point actually starts here on this graph. So on the sine of 2t, cosine 2t, our initial point's here, not over here like it was before. Also, when we travel around the circle now, so if I hit over to keep increasing my t, you can see the direction it's moving is actually clockwise now, whereas before it was counterclockwise. So this is traveling, here was our initial point, it's traveling this way around. Another thing you notice here is that we actually travel around the circle multiple times in this interval rather than just once. And so like if I keep tracing here, you can see we're moving counterclockwise, and by the time I get to 2 pi here, 2 pi is equal to like 6 something. My t's not even quite yet to 3, or now it's to 3. So it looks like it goes around 2 times in 0 to 2 pi rather than just 1 time. So there is differences among this graph. That's why we distinguish in parametric between a curve, which is a set of points, and a parametric curve, which has points, but it also is traced in a particular way. So although they trace out the same unit circle, this one has a different initial point. It also travels in a different direction, and it travels more than one time around that circle in the same amount of time or same amount of range in our parametric. So there's a different, you can get the same curve, but you will always have a particular parametric.